Hi, welcome, and thank you for joining us today. My name is Art Baudo. I'm a Principal Product Marketing Manager here at AWS, and I'm joined by Martin Yip. Martin, why don't you introduce yourself?
Hi, everyone. Happy to be here today. Yeah, my name is Martin Yip, and I lead product marketing for our EC2 compute and networking services. So looking forward to having this discussion with you today.
Yeah, today Martin and I are going to talk to you about differentiation with AWS Compute. Martin's going to rejoin us a little bit later in the presentation to go through some of our Graviton and AI ML processors, and we'll talk through some of that as we go through here. I'm going to get us started here, and give you a little bit of a background on Amazon EC2, and show you a little bit of what we do and some of the differentiation that we can offer you that you can use to differentiate yourselves as well. So once again, thanks for joining, and let's get started. So back in 2006, we launched EC2, specifically on August 26th of 2006. We launched EC2. And you can see here that we weren't even at that time, we didn't have the same perception of the cloud and cloud computing, which it's hard to believe that only 17 years ago is when the cloud got started here. You can even see from the blog post here that Jeff Barr, our VP and chief evangelist, wrote that it was very focused on, EC2 is launching, and he was even on a vacation in Cabo San Lucas, and that was the picture that he chose to post at the time. So wow, have things changed since then, and what have we delivered? And the cloud has become somewhat indispensable to all of us. Since 2006, over 30 billion instances have been launched in Amazon EC2. 30 billion. It's a huge number, and it goes to show you the depth and breadth of customers who have used Amazon EC2, customers such as yourselves that are out there, and perhaps some of you who would like to try out Amazon EC2. Another great stat is that over 100 million instances are launched every single day. That is a huge number, but I bring this up to talk about how our network and how our compute capacity is in order to be able to support those 100 million instances that are launched every day. It is the quality of the network that we have at Amazon is what enables us to enable customers such as yourselves and enables us to deliver these 100 million instances every single day. So our goal back in 2006 was to provide customers with the tools and services to securely and reliably run virtually any workload. And I'm happy to say that this is still one of our primary missions as well. We have two of them. The next one I'm going to bring up here in a second. But our goal, as we have continuously innovated and as customers advanced in the cloud and told us what they wanted to do, as a matter of fact, 70% of our new instances are taken off of customer feedback. And that is how we design our instances going forward, our instances that we've delivered. And the other thing is we continue to innovate continuously. It allows us to improve the overall performance while reducing cost. We've actually reduced prices over 100 times since we started in Amazon EC2. So this is a little bit of an overview of what we're going to talk about, allowing you to talk through me about how you can differentiate. So we're going to talk about this world-class scale and performance that we deliver. I'm going to talk a little bit about compute for all workloads, and we'll then talk about cost and how to do best practices with cost optimization, something I'm sure everybody out there is concerned about. And then we'll talk about compute and how we provide compute to you where you need it, when you need it. All right, let's start with world-class scale and performance. How do we design AWS? AWS is designed off of something called the Nitro system. The Nitro system is a series of modular building blocks that allow us to deliver our EC2 instances. This is what's behind the scenes. This hardware here comprises of our Nitro card, which delivers our NVMe storage, networking capabilities. It does monitoring. We have a security chip as well that protects the hardware resources from being compromised. And we have a lightweight hypervisor So we deliver all of these to help provide the easiest security, to provide security and allow rapid innovation on our side, and provide such a thin layer of 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 overhead here that you get near bare metal performance when you get your instances. So what is our Nitro system architecture? So our Nitro system architecture, at the fundamental level here at the bottom, you can see our Nitro system is comprised of the security, storage, and networking component. We then have a thin hypervisor that sits on top of that. And that thin hypervisor is there and helps with the management. And on top of that, in the server, we have the operating system or the instance OS. And that is what you build your application off of. And today, over 20 million Nitro chips have actually been shipped in the world. 20 million. That's how many chips that Amazon has developed, designed, and architected ourselves. So we have purpose built these chips for the cloud. And this is something that is a differentiator for Amazon as well. But you want something that is purpose built for the cloud. This helps us deliver on our design and helps us deliver on performance as well. That Nitro system, using Amazon EC2 instances, we can deliver over 15% higher throughput and performance versus competitors. What I'm showing here on the left shows you just spec in, which is bare kind of raw benchmarking information. But that's not really what most of you are using out there, just doing basic arithmetic. Most people are doing something with real world metrics. And on the right-hand side is where the Amazon Nitro system and our differentiator come in. This is where you can see the over 15% higher throughput, and in some cases, as great as 27% versus competition that are out there. It's like almost getting a full generation of silicon. So I talked about storage. One of the things that I know every one of you is concerned about when you do work is latency. Latency impacts your performance. And that's why we developed our Nitro SSDs. These are high performance, low latency SSDs that are custom designed by Amazon for the cloud. Our lower latencies reduce the amount of time it takes you to access memory, but it also reduces the latency variability. And that improves the reliability in your access time. And it also improves our overall. It also helps us deliver better security to you too. And I'm proud that just a couple of weeks ago, we announced our latest generation of these Nitro SSDs, our Amazon i4G instances here. These are our latest Graviton 2 storage-based instances. They offer the best storage performance per terabyte and compute performance per terabyte for Graviton-based instances. So you get up to 1 terabyte of additional memory and 25 gigabits per second of networking. This is a great way to use SSD in the cloud off of Amazon here. And for those of you that are looking for anything using OpenSearch, using SQL databases, etc., this is a really excellent way to move storage. Okay, so I talked briefly about Nitro, but I want to mention that Nitro is part of our security portfolio as well. AWS Nitro allows us to deliver encryption, end-to-end encryption for our systems. We actually make sure that our systems are all use secure boot when they launch, so protecting them against any hardware or software issues. Our patching is such that only Amazon can patch software, so someone else outside has no access to patch the software. We're able to seamlessly do that to not impact any of our customers. And the most important tenet is there is no remote access. Something I want to mention that we, in our transparency here on access, no operator from Amazon can access any of your workloads or your data. And as such, we conducted an architectural review of our Nitro system, and we recently published that data using a company called NCC Group. You can take a look at our video and our information online about this validation, but this further shows our commitment to transparency and to security of the Nitro system for you. So I'm going to next talk about compute and compute for every workload. So over time, we've taken quite a few leaps. I mentioned back in 2006 where we got started. It's hard to believe that this is the processor, our M1 processor that we started with in August of 2006. We delivered 1.7 gigahertz Xeon processor at that time and only 250 megabits per second of bandwidth. And at that time, we thought these numbers were through the roof. Now, we've improved that. And today, we offer the broadest choice of processors and architectures, from Intel and AMD on x86 to our own Graviton, which uses ARM-based processors, to Mac M1 instances that we'll talk about today. I'm going to cover our Intel instances and launches. We have been working with Intel since the beginning, since 2006, and they're an important part of that portfolio. After that, we've also supported AMD instances. We were the first in the cloud to launch AMD instances in the AMD EPYC instances starting in 2018. We've continued that innovation. As a matter of fact, we have now launched up our C6A, M6A, and R6A instances, which is a significant performance upgrade. These instances deliver a 10% better cost compared to other x86 instances that are in the cloud. And so both our Intel and AMD instances, we're delivering the best in class versions of those instances here in the cloud for you to get started with. I'm going to turn this back over to Martin here so that he can join us and talk to all of you about our Graviton processors, which are a key component of what we're able to deliver and how you can differentiate with us. Martin?
Thanks, Art. As Art mentioned, we have an awesome partnership and a deep relationship with both Intel and AMD. However, we realized years ago that we wanted to further push the envelope on price performance for our own customers and our and their workloads. We knew that we would have to develop our own chips. In 2018, we launched the first generation Graviton and Graviton-based instances. And then in 2020, we launched Graviton 2 processors. And this is where it really took off. Graviton 2 processors provided customers with 40% better price performance for a broad range of workloads over x86-based instances. Today, we have 12 Graviton 2 instances across our entire portfolio, spanning from everything from general purpose workloads to even Graviton instances with accelerators in them. And these provide customers with the right mix of memory and storage and compute that they need for their workloads. And thus far, we have seen really good traction and adoption of these Graviton-based instances. Over 40,000 customers, including 48 of the top 50 customers, have adopted Graviton-based instances. Really tremendous adoption. But we knew that when we started Graviton that just having a great processor instance was enough. We really had to work with the ecosystem. So we worked with our ISV community, and we knew it would be very important to make sure that customers can just run their workloads, build and run their workloads seamlessly. Today, all major Linux operating systems support Graviton, along with container runtimes and really a growing number of AWS services. So whether you use Graviton through an EC2 instance or you go through a managed AWS services, you can rest assured that you're getting the price performance benefit that Graviton offers. So in 2022, we launched Graviton 3 processors, which offers 25% more performance on top of the 40% better price performance that I already talked about with Graviton 2 based instances. Earlier this year, we continued with our innovation by launching M7G and R7G instances, which complete what we call the core CMNR Graviton based instances. CMNR is really the core of what our customers use, the bulk of it. Now they're able to use Graviton 3 for a broad set of their workloads as well. Today we have over 16 Graviton based instances across our portfolio, providing customers the right mix of memory, storage, and computing needs. And these Graviton based 3 instances are great for everything from compute intensive workloads to open source databases, web servers, and streaming, and so much more. Let's jump into an example and talk about what customers have done with Graviton. Formula One, perhaps one of the most famous racing sports out there, had been a Graviton 2 customer and had great success with Graviton 2. They had already seen Graviton 2 based C6GN instances provide them with the best price performance for their computational fluid dynamic workloads. But when Graviton 3 came out, they got really excited and they tried them and found that Graviton 3 was even better. Graviton 3 C7G instances provided them with 40% faster performance than Graviton 2 for the same simulations. So with a simple switch in an instance, you're able to get so much more performance. And with the improved price performance, Formula One found that Graviton 3 based instance became the optimal choice to run all of their CFD workloads. So really, really fantastic how Graviton's impacting the world of motor car racing. But it's not just about performance; it's also about energy. And one of the things that we're really proud of is our efforts in sustainability. Graviton 3 not only provides great performance and price performance, but also uses 60% less energy for the same compute workloads as comparable x86 instances. So really tremendous. And in some places, this is even more impactful as we realize that certain countries are further behind in sustainability. Just moving from on-prem to cloud and Graviton has an even bigger impact on sustainability. Let's shift gears now and talk about another workload that customers have been excited about. Let's talk about EC2 Mac. With over 34 million Apple developers and over 2 million applications created by AWS, has been working with customers to support their Macs out there. Last year, we launched our EC2 M1 Mac instances that enable Apple Silicon environments for the first time in AWS. Customers re-architecting their Mac OS applications for Apple Silicon Mac computers can now achieve faster builds with bare metal performance and convenient distributed testing without having to procure, install, patch, and upgrade their physical infrastructure. Customer feedback thus far has been amazing, and we've seen thousands of customers migrate and modernize their Apple builds. And these aren't just any customers; these are big customers, including folks like Pinterest and Intuit and Goldman Sachs and Riot Games and Pokemon and Groupon, and there's just so much more. They've reported up to 4x better improvement in their build performance, as well as 3x increase in their parallel builds and 80% reduction in their build failure. So just tremendous overall improvement in their Apple environment and Apple builds. Let's shift gears again. Machine learning has been a big topic this year. And machine learning is really powering breakthroughs that impact every aspect of our lives, from cars that drive themselves to voice assistants that hold conversations to recommendation systems and much more. Enterprises and startups in every industry are using machine learning to solve problems in new ways and offer customers just better customer experiences. Now, when we think of machine learning, there are two types of machine learning that we focus on. The first is training, which is the process used to create new models. And then there's inference, which is where you deploy those models and generate predictions based on the input. Every year, we have over 30,000 customers build, train, and deploy machine learning applications using our EC2 infrastructure. And we offer a vast portfolio of machine learning infrastructure, everything from instances for training and instances for inference. We, again, partner with industry veterans like NVIDIA, as well as Intel. We also build our own silicon with Trainium and Inferential, which I'll talk a little bit about in a bit. So as ML goes mainstream, more and more customers are adopting machine learning to drive business efficiencies and better customers' experiences. Models are increasing in size and complexity. Let's just give into perspective, 3 years ago, a large machine learning model would have been millions of parameters or hundreds of million parameters in size. Today, we're seeing models that are hundreds of billions of parameters, if not trillion parameters in size. So just huge growth in size and complexity. And AWS has been monitoring machine learning trends and noted that there's a rising cost in compute, and customers could benefit from more powerful and cost-efficient alternatives. We've been working on designing and building silicon for over a year, for over for over a decade now. And as I talked about earlier with our Graviton processor, we had relative success for our generalized computing portfolio, but we believe that we can apply the learnings from Graviton and from Nitro that Art talked about to really building silicon for our ML workloads. So that's why we introduced our Inferential line of machine learning training. And just last month or earlier this year, we had introduced Inferential 2 based instances that are optimized for really large language models, models that are over 100 billion parameters in size. These Inferential 2 based instances offer 70% better price performance and 50% better performance per watt than comparable Amazon EC2 instances. Let's dive into some of the data that we're seeing in the next slide. So if you look here on the chart, the benefits we're seeing are just tremendous, right? Customers are able to, get inference for their workloads with 50% fewer instances. So they're ultimately using less instances as these instances are more powerful. They're also able to save on energy cost. Again, the reduction in the number of instances and also just the efficiency of the chip itself is driving 50% less energy used for the same performance. And then, a big one is just the lower costs, up to 65% lower cost in the cost of inference. So just tremendous value and benefit coming from the inferential side. But of course, inferential is just one part of the equation. We also offer chips and instances for training. And earlier this year, we also updated our Trainium portfolio with TRN1N instances that now come with 1600 gigabits per second of network bandwidth. Now these Trainium instances, both Trainium TRN1 and TRN1N, they offer tremendous value in terms of high performance as well as up to 50% lower cost of training over comparable Amazon EC2 instances. And again, let's look at the data a little bit on the next slide. So significantly faster training, up to 2.3x faster training than other comparable EC2 instances. Again, much lower energy consumption, 47% less energy for the same performance, and then 72% lower cost to train. So just tremendous overall, better performance, lower cost. It's a win-win situation. So really excited about that. Now let's switch gears a little bit, as we know that cost is a huge issue, and customers are looking to better optimize cost. Picking the right instance is definitely a first good step, but there's definitely more to know. So cost is constantly important to Amazon. And in fact, frugality is one of our leadership principles, and it's built into our DNA. We're able to offer customers better price performance for diverse workloads in the cloud because of several factors. First is our economies of scales. We are the largest cloud provider, and we are able to pass on the scale and just the economies of scales to our customers. We make a deep investment in our silicon leadership, as I talked about, with not just our partners, but also with our own silicon and Graviton and Trainium and Inferentia that enables performance, security, and innovation across our platform. We offer broad choice in architecture so that customers can make the right choices to pick the right instance for their workloads to make sure that the infrastructure is tailored for their workload needs. And then we really focus on helping customers save through our purchasing options, whether that's through spot instances or savings plans or something else, or even on demand. And then finally, we help customers optimize their usage through something we call Cost Optimizer, where we use machine learning algorithms to understand the customer's usage pattern and make recommendations to them so that they can ultimately pick the right infrastructure and ultimately save money. So really, really great cost optimization techniques for our customers. Let's move on. So I'm going to wrap up today with just talking about offering compute where you need it. We talked a little bit about scale earlier on, and AWS is able to offer scale and performance for our customers. Looking at this chart here, you know, our network is really the cornerstone of what made AWS and cloud computing successful. When I talk about network, it's not just about networks within our data center that connects our servers together, but it's really our network that connects our availability zones and regions together. Let's take a closer look. Today we have 31 regions span globally across the country, across the world, and we have 5 more regions coming extremely soon, coming very soon. So you know, wherever you are in the world, you should be able to access a cloud computing region and get access to highly performant cloud infrastructure. Next. So then, you know, we understand that there aren't regions in every single country or every single major metropolitan area, and customers really want low latency. So a few years back, we introduced local zones, and local zones brings AWS compute, storage, databases, and other AWS services close to large population and industry centers. It really allows customers to run low latency applications at the edge, like real-time gaming or AR, VR, or even virtual workstations, where latency is a really, really big, important dimension of a good experience. And we also want to help customers simplify hybrid cloud migrations while still meeting those low latency requirements. So local zones can help customers meet those stringent data residency requirements in sectors such as healthcare, financial services, gaming, and even public sectors. Let's move on and talk about Outposts. So, you know, some customers want the infrastructure even closer to where they are. And in some cases, they want the infrastructure in their own on-premises data center. So in 2019, we introduced AWS Outposts to deliver AWS infrastructure and services to customers' on-premises locations for a truly consistent hybrid experience. Outposts are available today in 65 countries and 23 AWS regions, including our GovCloud region and many of the countries around the world. And we'll continue to support with new regions when they launch. Outposts has really enabled customers to build innovative applications using AWS services on premises. I want to just wrap up with another customer example. This time I want to talk about NASDAQ, and this really brings everything that Art and I have talked about together today. So NASDAQ needed compute in many spaces. They required bare metal performance in order to migrate their financial exchange into the cloud. And to do this, we combined AWS Outpost along with AWS regions and AWS local zones in order to meet the required latency requirements that they had, especially with trading where you need just the real-time milliseconds and can't really do count in things like trading systems. So really able to offer them a combination of outposts, regions, and local zones to help meet their latency requirements. And over the past 3 years, NASDAQ has worked really close with AWS to really team to validate and finally tune the Outpost solution to operate under the demands of some of NASDAQ's ultra fast and high volume markets. And we're really happy to continue this partnership with NASDAQ and make them successful wherever they need their compute. In closing, we're going to welcome Art back on screen. Personally, I think we're just at the very beginning of cloud computing and where we are with this journey. I really do hope we never allow ourselves to be comfortable with where we are. And I really do believe that we will innovate for many, many, many years to come.
Yeah, Martin, this was a great presentation where we were able to kind of talk about so many of the innovations that we've delivered since 2006 and the opportunities for customers out there to save money, whether it's for using machine learning or using our Graviton-based silicon, is tremendous. In addition, the excitement we had when you talked about the efficiency of what we've been able to do, the savings that customers can get from a sustainability perspective is just tremendous here. And this is a great way to just get started. It's an exciting future, I think, that we see out there. And I agree with you. I don't think we are comfortable where we are. We're looking at so many innovations that are to come here from AWS. And I just want to extend a thanks to everybody out there and thank all of you for joining us today.
Yeah, it was a great discussion. Thanks, everyone.